Hello, my name's Mark and I am G-Code Tutor, and I'm here today with Practical Machinist to continue this series of lessons on programming a complete part with G-Code. Today we're going to look at two different ways we can PEC drill. Okay, so let's jump straight into it. I'm going to start off with my search number N6 and an operator's note here in brackets telling us what drill we are using or what tool we are using. So we're using a 1/4 of an inch drill here. Now, of course, everything in brackets is not read by the machine. Now, each line finishes with an end of block sign, that semicolon there. So the next line is our safety line. Now I've gone through this in a lot of detail in previous lessons. If you look back on the previous lesson in this series, the center drill, I talk about it a great deal more there also. So this next line is our tool call. This is where we bring our tool into position so we can start machining with it. So T06 calls our tool that's in position 6. And the second 06 there is our datum table information that tells the machine all about the geometry of that tool so it knows where the cutting edge is. And MO6 is our tool change M code. So it's going to do a tool change at this point and bring tool 6 down to the center line ready to start cutting. Now this next line here, MO3 S1000, turns the spindle on in a clockwise direction and sets the spindle speed to 1000 revs per minute. Now if your tools are loaded upside down, you might need to use MO4 here. Now the next line we're going to start moving around. We're going to start off with a rapid move, G00. Now we're bringing it down to the center line of the part, it's X0, and we're moving in 1/2 inch away from the front face of that part. So we've got plenty of clearance there as our tool is coming in. And I also turn on the coolant at this stage with MO8, so those pumps will start up as the tool is moving into position. So hopefully by the time it's there, the coolant should have started coming out of the tool. So I've split this into two separate lines. The second line here, I've got another rapid move that takes the tool slightly closer to the face, only 1 millimeter off that face or 40 thousandths of an inch. So I do this in two lines for safety reasons. It makes setting up a lot easier. And then we can also make sure that tool is in position as it's rapiding in to 1/2 inch away. If it's rapiding into 40 thousandths of an inch away, it's hard to see whether it's going to collide with a part or not. Okay, so now this line is what this lesson is all about. I'm going to show you two different ways that we can use a PEC drilling cycle. So our tool is currently 1 millimeter away from the face of the part at 40 thousandths of an inch. Now our Z depth there is the final depth of the drilled hole. So we're going down to minus 2.2 inches. And then we have a Q values, Q400. So this is the depth of each PEC. So the Q value here doesn't need a decimal point. It's actually going in at 0.4 of an inch before it retracts after its first PEC. So each PEC is going to be 0.4 of an inch. Now this R value here, this 0.7, this is the retract value. This is how far the tool is going to retract after each PEC. And then finally a feed rate. So I've given it 6 thousandths of an inch per revolution of the spindle here for a feed rate. And we've got 1000 revs per minute moving that spindle. Okay, so that is your standard G83 PEC drilling cycle. But we can make it much more fun than that. We can do a variable PEC drilling cycle. So this gives us much more control. If you're having troubles with drills breaking, you're having troubles with a PEC, it might be worth trying out this other method. So let's take a look at this other method to produce variable PEC drills. So again, we start off with G83, and again, our Z depth is the final depth of the drilled hole. But then we have also our retract value, which is the same. We can still use R, so I'm still using the retract value the same as before. But here we have I, J, and K. So this is the extra bit. So this is what they do. So I decides the size of the first cutting depth. So when we're drilling in, it's going to go to the depth of I before it retracts. So this time we're taking 0.7 of an inch cut before the first retraction. Now J is the amount of reduction of each depth of PEC. So every time it PECs, it's going to reduce that depth by 0.1 of an inch. So the next time it PECs, it's going to take 0.6 depth of cut, then the time after that 0.5, then the time after that 0.4, etc. But the only problem with this is it can keep going down to eventually we're only taking depths of cuts of 1 or 2 thou, which could take forever to drill a hole. So because of that, we need to issue a minimum peck depth. And we do that here with the K value. So this K 0.5 means it's not going to take a cut smaller than ½ inch. And then finally, a feed rate. So it's pretty much the same, but we've got those IJs and Ks there. So I is the size of the first depth of cut. J is the amount of reduction of each depth of peck. And finally, K is the minimum peck depth. So by using variable peck drilling, it gives us a little bit more control, and we can help drill those problem materials that may be binding up or giving us some problems there, maybe breaking drills, etc. So that's the variable way we can peck drill. Okay, so after any cycle, we need to cancel it with G80. Of course, if we have to stop the machine halfway through that peck cycle, start on a different sequence, we do have that G80 also in the safety line that will cancel it there. But after all cycles is finished, we need to issue a G80. So we're going to issue that G80, and that's going to tell the machine there is no more cycles active, and we're just doing normal point-to-point kind of machining from now on. So talking of which, we're going to rapid for our next command. So G00Z1 brings that tool well away from the part, an inch away, and it moves there rapidly. So with our tool at a safe distance away from the part, we can now send it home ready for its next tool change, ready for its next sequence. So we're going to switch over to the machine datum, G53, and then send it back to its 0 position, that's X0Z0. So the machine is now back into its machine 0 position, which is usually where tool change happens. It might not on your machine, so beware not all machines do the tool change in the machine 0 point, but often they do. So as the machine is taking the turret back to its machine datum point, I'm turning off the coolant here with MO9. So once the tool's safely out of the way, we can now stop the spindle with MO5, then finally MO1, my optional stop that I always end each sequence with. So that's how we do a peck drill and a variable peck drill on a CNC lathe. Now if you want to know more about peck drilling, CNC lathe programming, milling machine programming, I have a range of courses over on my website at gcodetutor.com, where I teach G-code programming, computer-aided design, computer-aided manufacture, machine shop maths, tool calibration, and many other subjects. So pop over to gcodetutor.com to learn more about machining.